discuss this example. So in this example, we have a function from Rn to R, getting, and it is defined in very simple way, which is equal to C. C is a constant, okay. C is any real number which is a fixed constant. We have to prove it is differentiable, and we have to find its total derivative. In our previous two videos, we have seen how to solve problems, right? So I will follow the same method to solve this problem. First of all, I will write the given function. We have, see, what is a given function? Function is f of x1, x2 and so on xn is equal to C. I am writing x1, x2 and so on xn since domain of this function is Rn. After that, we have to take point A and H. A is not given, so I will take any arbitrary A. Let A is equal to A1, A2 and so on n, and H is equal to H1, H2 and so on Hn. Okay, so I have taken two elements of Rn. After that, we need to calculate two terms first, f of a plus h and f of a. Let us find them. Consider f of a plus h, which is equal to f of, you know that a means what? A1, A2 and so on n, and h means H1, H2 and so on Hn. So you know well how to add them. We need to add component wise. So this is f of a1 plus h1, a2 plus h2 and so on n plus hn. So after that, we have to find its value. Let us follow the definition, given definition of f to find its value. The definition says its value is C, simply C. Whatever inside the bracket doesn't matter. A1 is there, B1 is there, C1 is there, doesn't matter. Its value is fixed, which is C. So here also we will have C. After that, we will go for f of a. Now, f of a, which is equal to f of a1, a2 and so on n. So here also I will follow the same definition of f, which is C, doesn't matter, a1, a2 or whatever inside it, its value is fixed, C. Then we find the difference between them, f of a plus h minus f of a. So f of a plus h we have got C, and f of a is also C. So let us put them, C minus C, 0. That is, this is a very important step, 0 we have got. With the help of the difference between them, we need to define the linear transformation. Let us do it. We define a linear transformation. We define a linear transformation T from Rn to R. See, T should be from Rn to R since function is also from Rn to R, as we are defining in this way, T of H1, H2 and so on Hn. So how we decide the definition of T? By observing the difference between them. If there is any linear term, we define as T. But as you can see in this example, the difference is 0. So obviously our definition of T is also 0. Okay. So f of a plus h minus f of a we have calculated. We have defined linear transformation also. So let us find that term which we normally see in definition. So consider after that what we find? We find f of a plus h minus f of a minus t of h. So f of a plus h minus f of a is 0. T is also 0. 0 minus 0, 0. So the difference we have got 0. After that, yeah, we have defined that linear transformation, that is nothing but total derivative. We know that is a required total derivative. But with the help of epsilon delta definition, we need to prove that really it satisfies that epsilon delta definition of total derivative. Then only we can declare it. You can make a screenshot of it. After that, we will go further. For epsilon delta definition, we need to take one epsilon first. Let epsilon greater than 0 be given. So for this epsilon, we are supposed to find delta, which will satisfy the definition. But see, fortunately, the important term, that f of a plus h minus f of a minus t of h, we have got its value 0. So no need to worry, for any delta it will work. Let delta be any positive real number. That means actually it doesn't matter the value of delta. For any delta it will work. Let us prove. Consider, so I am going to consider norm h less than delta implies mod f of a plus h minus f of a minus t of h divided by norm h, which is equal to, let us find its value. So we have already got its value 0. 0 upon norm h. Let me remove it, it is not required now. So 0 upon anything 0, and 0 is less than epsilon. Okay, so we got it's less than epsilon. So therefore I will rewrite the same thing actually. Norm h less than delta implies mod f of a plus h minus f of a minus t of h whole divided by norm h less than epsilon. Getting? So yeah, definition is satisfied. So we can write the same thing in terms of limit, that is limit h tends to 0 mod f of a plus h minus f of a minus t of h divided by norm h is equal to 0. Getting? So definition is satisfied. That's why we can declare it is a f is differentiable at a. Therefore f is differentiable at a belongs to Rn, and its total derivative is we denote in this way, df of a of h, which is equal to t of h, and you know the definition of t is 0. So total derivative is 0, and you know that if function is constant, derivative is 0. So that's why here also we have got total derivative 0. Getting? And see, but a belongs to Rn is any arbitrary point. It is any arbitrary point. So therefore function is differentiable at each point. So therefore f is a scalar field. Therefore f is differentiable at each a belongs to Rn. Therefore f is differentiable scalar field. So DIFF means differentiable everywhere I use. Okay, you can make a screenshot of it. After that we will stop. Thank you. Bye bye.